Welcome to my video on percent proportion. So in our previous unit, we covered proportions, and now we're going to be mixing in percent. So we're going to have to remember our prior knowledge about percent and what it's out of. So recall that percent is a special ratio in which the denominator is 100. So percent is always out of 100. A percent proportion compares part of a quantity to the whole quantity, also called the base, using a percent. So here's what the equation looks like. Part over whole equals percent out of 100. Okay, so it says use keywords to help you set up a percent proportion. So the whole, or the base, represents the denominator. The blank represents the numerator. That's correct, the part. And the blank amount is always followed by the percent sign, or it says percent. So of course that word is percent. If they're talking about a percent, you'll always see the word percent after it, or you'll see the symbol right here meaning percent. And of course you always put the percent number over 100. So fill in right here, fill in 100. Okay, now we're going to look at two examples on this page, and we'll look at several more on the next page. So remember, part over whole equals percent over 100. So a factory is operating at 80% of capacity. The capacity is 300 cases per hour. How many cases are being produced each hour? Okay, so we have a percent here. So we're going to put 80 over 100. And now I have to decide what I'm going to do with the 300 cases. I know some of you were thinking maybe the per hour fits into this, but no, they're just telling you how many cases you make an hour. You want to know how many cases can be produced, and they're saying that it's 80% of capacity. And they're saying the capacity is 300 cases. So if the capacity is 300 cases, do you think that would be part or whole? If you said whole, you are correct, because that is the most cases that they can hold in that hour. Okay, so then we're going to find part, which is on top. And now, just like we did in our last unit, we're going to circle our variable first. So 100 times x is 100x. And 80 times 300 is 24,000. So now I'm going to divide both sides by 100. 100 divided by 100 is a 1 in disguise. So the answer is 240 cases. And then go ahead and circle your final answer. And let's see if that makes sense. 240 cases are being produced each hour, and the capacity is 300 cases. So do you think that's maybe about 80%? Yeah, that seems reasonable, because 240 isn't that far away from 300, and 80% isn't that far away from 100%. So that's reasonable. Okay, let's look at number 2. There are 33 people at a meeting. 40 people have been asked to attend. What percent of those asked attended the meeting? Okay, so we're looking for percent out of 100. And do you see a percent here? No, because they're asking me for the percent. So I'm going to put x over 100 since I want to know what the percent is. And now I have to figure out if 33 is the part or the whole. So let's look at this. 33 people are at the meeting. 40 people were asked to attend. So if 33 people were at the meeting, is that all the people or only part of the people that were invited? Hopefully you said part of the people invited because there were a total of 40 people invited. So if all 40 came, that would be 100%, but only 33 came. So now we're going to solve this. So 40 times x is 40x. 33 times 100 is 3,300. And now what do we do to both sides? That's correct, divide by 40. 40 divided by 40 is a 1 in disguise. And so the answer is 82.5, and I have to put the percent sign. If I leave the percent sign off, it is wrong. It changes the value of the answer. So 82.5%. So let's see if that's reasonable. 33 compared to 40. 33 is fairly close to 40. 82.5% is fairly close to 100. So that seems reasonable. Okay, moving on to number 3. And I misspoke earlier. I only thought there were 2 examples at first, but there are 3 on the first page. So it says only 13 students were absent from school. This was 4% of the enrollment. What is the school's enrollment? So we have a percent this time, and it says 4%, so 4 out of 100. And there's 2 ways to figure this out. Number 1, you can just say 13 students absent from school. Is that part or whole based on the whole school? And that, of course, is part. So you can put 13 over x. Another way that you can also tell that that is a part is it's saying this number right here is 4% of the enrollment. So only 13 students were absent from school. This was 4% of the enrollment. By that statement, they're telling you that that's a part because those 13 students only represent 4%. If it represented all of them, then they would be talking about 100%. But they're only talking about just part of the students. So they want to know what is the school's enrollment. So they're looking for the whole. So 4 times x is 4x. 13 times 100 is 1,300. And you divide both sides by 4. And of course, the answer is 325 students. Okay, if you feel fairly comfortable at this point with the material, you can go ahead and pause the video and work out all the problems, and then turn the video back on and just fast forward through so you can see if you did them correctly. So I'll let you make that decision. So let's look at the next page. During a basketball game, James attempted 15 baskets and made 6. What percent of the baskets did he make? So is this question asking for part, whole, or percent? Hopefully you said percent, so circle the percent, because it said what percent of the baskets did he make? So we're looking for the percent, so x over 100. And now, James attempted 15 baskets and made 6. So if he attempted 15, is that part of the baskets or all of the baskets? That, of course, would be all of the baskets. And then how many he made is only part of his total shots. So 6 would be the part. So now 15 times x is 15x. 6 times 100 is 600. I divide both sides by 15. 15 divided by 15 is a 1 in disguise, and so x equals 40%. So write in 40%. And again, if you forget the percent sign, it is incorrect. Okay, number 5. Bob's team won 75% of their baseball games. They played 16 games in all. How many games did they win? So I want to know how many games they won. So is this question asking for part, whole, or percent? Now think about it. We know that they played 16 games and we know they won 75%. So how many games they won, is that part, whole, or percent, do you think? Yeah, how many they won is the part. So we are looking for the part. So we have a percent, so it's percent over 100. And they played 16 games total, so that is the whole. And since we're looking for the part, we need an X in the part spot. So we're going to circle our variables. So 100 times X is 100X. 75 times 16 is 1,200. We're going to divide both sides by 100. 100 divided by 100 is a 1 in disguise. And 1,200 divided by 100 is 12 games. Now, let's see if that is reasonable. So they won 12 out of 16 games, and that's supposed to be 75%. Is that reasonable? Yeah, because 12 over 16 would simplify to 3/4, and we know 3/4 is 75%. Now, we never check back to see if this is reasonable. So half of 15 would be 7.5. So is this number less than 50%? Yes, and our answer was less than 50%. So 40% is reasonable for 6 out of 15, because if he made less than 7.5 shots, then he made less than 50%. So in looking at both of these, they're both reasonable. So let's look at number 6. Last season, 20% of the base hits made by a ball player were home runs. The player hit 42 home runs. How many base hits did he get? So, is this question asking for part, whole, or percent? Now, we know we have a percent here, so they're not asking for percent, and we know he hit 42 home runs. So, 42, would that be all of his hits or part of his hits? Hopefully you said 42 home runs would be part of his hits. So how many base hits did he get? We are looking for the whole. So we know that percent is out of 100. And we know that 42 is the part, because 42 home runs is not all of his hits. Okay, that's just part of his hits. So now we're going to do x times 20, which is 20x. 42 times 100 is 4,200. And we're going to divide both sides by 20. And 20 divided by 20 is a 1 in disguise. And 4,200 divided by 20 is, of course, 200 hits. Now, let's see if this is reasonable. So 42 compared to 210 is not that much. And so our percent is 20%. So is it reasonable to think that 42 out of 210 would be about 20%? And the answer is yes, it is reasonable to think that. Okay, our last problem of the day. Kylie tested 12 batteries and found that 2 were defective. What percent of the batteries were defective? Okay, so we're looking for what here? That's correct. We're looking for a percent, because it said what percent, and notice all the answers have a percent sign. So now it says what percent were defective? And we know we tested 12 batteries. So is 12 batteries all of them or part of them? That's correct. 12 is all of them, and then the ones that were defective is just part of them, because they weren't all defective, just part of them were. So now 12 times x is 12x, and 2 times 100 is 200, and we're going to divide both sides by 12. And our calculator says 16 and 6/10 repeating, and we have to put a percent sign because we're looking for a percent. Now I don't see that answer here, but what I do see is 16 and 2/3. And if I recall, 2/3 is 0.6 repeating, so they do in fact match. And if you weren't 100% sure, you could just take 2 divided by 3, and the calculator would say that it's repeating, and then if you stick the 16 in front, then we have what we got here. So that concludes our notes on percent proportion. I hope you have a great day.